everybody? Welcome to another video. Hope you're ready to flex those brain muscles. In this video, we're going to talk about these special triangles, and we're going to talk about what makes them special and how you can actually use them to build the unit circle. It's really cool. You don't have to stare at the unit circle until you memorize it. If you understand these special triangles and you can recognize some patterns, you can gain a deeper understanding with why the unit circle is the way it is. And using that deeper understanding, you can build the unit circle and draw it from scratch. You can find values for your trig functions faster. Just everything gets a little better, right? It gets more fun when you have a deeper understanding, when you can make these connections. So hopefully we can do this. Let's go ahead and start. All right, so the reason we call these special triangles is because for 45, 45, and 90-degree triangles, there is a specific relationship that we can find in general between the three side lengths. Same goes for 30, 60, 90. It's not the same relationship, but we can find a different relationship between the three side lengths of a 30-degree, 60-degree, 90-degree triangle. So I'll prove each one of these right now. Let's start with 45, 45, 90. That seems to be a little bit simpler one. So again, these are both right triangles. So in this case, I have 45 degrees here, 45 degrees here, 90 here. So I'm going to write out the 45s. 45. This is 90. I just used that little box to show that it's 90. So I'm going to call the hypotenuse R. You can call it whatever you want technically. I'm calling it R because I'm kind of planning ahead, because I know R is what we use when we refer to, you know, our trig functions and the unit circle and all that stuff. So R is what I'm calling the hypotenuse. So I don't know what these sides are, but I claim that I can find a relationship. And what's going to end up happening is I'm going to find these side lengths in terms of R. So basically these will depend on what R is. So to make sense of that, what can I say? Well, I can say 45 degrees and 45 degrees. Both of these angles are the same. Therefore, the side length across from them must be the same. This is actually a rule from geometry, okay? So I can call both these x. I don't know what it is, but I know they're the same, and I know they're x. So now we can use a little trick called Pythagorean theorem. I guess it's not really a trick, but that's what we do. Pythagorean theorem, x squared plus x squared equals r squared. These are like terms. I can combine them. 2x squared equals r squared. We're getting warmer. Again, I want to solve for this x, and it's going to end up being in terms of r. So I can divide both sides by 2. Bam, those 2's cancel. I have x squared equals r squared over 2. Now what can I do? Square root both sides. Do I have to worry about any plus or minus? No, these are all side lengths. They're all positive, okay? So I have x equals r over root 2. Okay, so now this is correct, but we do something called rationalize the denominator. Why do we do that? Well, it's what all the cool kids do. It's what we do in math. We just follow the cool kids. So root 2 times r over root 2 times root 2, that is 2. So what can I say? Any side x, okay, well, let's say it this way. For a 45 degree, 90 degree triangle, whatever the hypotenuse is, we can multiply the hypotenuse by root 2 over 2 and get both the other side lengths. That's what we've just shown. So I can replace this x with root 2 over 2r as well as the other x. And now let me go ahead and show the other triangle. All right, so before I actually move on to this triangle, I just want to show how we can relate this to the unit circle. So as we know, the unit circle, it has a radius of 1. The center is the origin, 0, 0. So since the radius is 1, you've probably seen the points all along this before. It may be a little overwhelming to look at it first. But since the radius is 1, what can we say? Well, we can put a triangle in here, right? We have a radius 1. So this distance can be 1, and then I could draw down. And a triangle can fit in here. And that's why we call this hypotenuse r, right? It's because that hypotenuse of this triangle is also the radius of our unit circle. So if we have a radius of 1, what can we say about the other two sides? They are root 2 over 2 times 1. Both of these sides, which is just root 2 over 2. And that's where this point comes from. For 45 degrees, or pi over 4 in radians, we have root 2 over 2, comma, root 2 over 2. So the way I think of it is this triangle with a hypotenuse of 1, that's a 45, 45, 90 triangle, can basically fit inside our unit circle. And since we know that this is 1, and this distance must be root 2 over 2 as well as this distance, and what are those distances? What are those side lengths? Well, those are just the x and y coordinates. and that's why we have root 2 over 2, comma, root 2 over 2 here. So hopefully that makes sense, and we can actually, what could we do? Well, we could flip this same triangle. We can reflect across the y-axis and get the same points here, but what's the only difference? It's in the second quadrant. We've just positioned it differently. This length is still the same, this length is still the same, but now the x is negative. So now I have negative root 2 over 2, comma, root 2 over 2. And we'll do more of that in another video. But I just wanted to show that. So again, we're trying to make connections between things. The less memorizing, the better. The more understanding, the better. So let's show this 30, 60, 90 triangle. And the advantage of us now knowing this is that when I get my R for this, I may just go ahead and plug in 1 to see if it'll make it easier. So 30, 60, 90. This drawing is probably going to be terrible. Let's see. Since I have 30, I'm going to have my 30 here. So this angle is smaller. All right. It's about as good as it's going to get. So this is the 30 degrees. This is the 60 degrees. That's my 90 degrees. So the way I do this triangle is I reflect it, right? I sort of mirror it. And by doing this, I can form one equilateral triangle, which means all the side lengths are the same. Because if I mirror it, I have 30, and now I've added another 30 degrees, okay? So this full angle has become 60 degrees, and I have 60 degrees here, and since I mirrored this angle is 60 degrees as well. So they're all 360 degrees, which means what? Well, that means my side lengths are equal, okay? So if I want to call this R, that means this full length is R as well. Which means that, well, I'll go ahead and write that. This full length is R as well. Which means that what? This side is just half of R, okay? So I'm going to actually erase that and just write 1/2 R, because I'm not concerned with this full triangle. I'm kind of drawing the full triangle as a trick to solve this, to get this general relationship. But I don't care about this side. I just want to solve this part, right? So I have R, I have 1/2 R. How can I find this side? Pythagorean theorem. I have two sides of a right triangle. I can find the third side using Pythagorean theorem. So I'm going to call this x for now until we know what it is in terms of r. And now I can write what? X squared plus 1/2 r squared equals r squared. So I'm going to go ahead and write that out in a formula down here. X squared plus, and this whole 1/2 r is squared. Be careful with that. 1/2 r squared equals r squared. So 1/2 times 1/2 is 1/4. R times r is r squared. So that becomes 1/4r squared. And we still have the x squared out here. And again, I'm trying to solve for the x. So basically what I'm going to do is, well, you know, I said I could plug in 1 here. And I guess it does make it easier in this case because then I have 1/4 and 1. So yeah, I'm going to go ahead and do that actually. I'll replace r squared with 1 squared, which is just 1. And the reason I'm doing that is because really the reason I'm finding this general relationship between the sides is to build the unit circle, you know. So let's go ahead and replace this with 1. So yeah, I just have 1/4 there. So I can subtract 1/4 to both sides. Minus 1/4, minus 1/4. And I get x squared equals 1 minus 1/4, that's 3/4. X squared equals 3/4, okay? So what does that mean? Well, square root. Square root. And again, I don't do plus or minus because this is a length. It's always positive. So that gives me x equals root 3 over root 4. Root 4 is just 2. So that gives me x equals root 3 over 2. Okay? And again, since my r is 1, I'm going to go ahead and replace these as well. Because I'm worried about the unit circle right now. 1, that's gone because 1 times 1/2, that's just 1/2. And we found this side length now, which is root 3 over 2. And again, I could replace this with r. This would be 1/2 r. This would be root 3 over 2 r. Okay? But I'm not too worried about that right now. So now I found the general relationship between these three side lengths. And now I can relate it again to my unit circle. So if I think of placing this 30-degree angle in here as the central angle, I'll have something like this. And I'm sort of thinking of fitting this triangle in the unit circle, okay? So I'm fitting this triangle. So this is my height, 1/2, and that's why that is the y coordinate, 1/2, okay? And this sort of base of the triangle is root 3 over 2. That's where these points come from. So wait a minute, what about this point? If you can remember back to the unit circle, we do have a point here at 60 degrees. Well, I can just kind of flip this triangle. I have 60 degrees here. So if my 60 degrees is there, let me think of sort of turning this triangle. I'll go ahead and do it right now. If my 60 degrees is there, okay, then this is my 90-degree angle, this is my 60 degrees, this is my 30 degrees. What does that mean? Well, the side across from 60 degrees is root 3 over 2. This is still the hypotenuse. So now this base is 1/2, okay? So now if the base is 1/2, that means what? That means my x is 1/2. And that means basically the height is root 3 over 2. So now I have all these 3 points, and again, these are 3 points on the unit circle, and I've plotted them not by memorizing, but by understanding that I can sort of lay these special triangles inside the unit circle, and that's how we get these points from the unit circle. I can reflect all of these across the y-axis. What will the only difference be? All my x's will be negative. I can reflect them across the x-axis down here. What will the difference be? All my y's will be negative. That's where I get all these points. All that I'm left to find after that is these points that lie on the quadrant. And those are easy. Like, look at this point. My x is -1. My y is 0. That's -1, 0. Those are easy to find. And then all I have to do is label the angles and all that stuff. We'll do that in another video. We'll draw the full unit circle. But I really hope this helps. I really hope seeing these special triangles and sort of laying them inside the unit circle helps some of you understand and hopefully remember the unit circle and be able to use it on your homework, exams, quizzes, all that stuff. So hit like if you enjoyed the video. Comment below, suggestions, questions, any of that kind of stuff. I'll read them all. And subscribe and keep flexing those brain muscles. I'll see you in the next video.